I am wearing a wire. Hey, today we're going to talk about systems of equations. So in your notebook, I want you to give yourself a title. And we'll glue all of those things in as we go along. Systems of equations. When I start talking to you about systems of equations, all it means is that we are going to have more than one equation. So for algebra 1, you will have 2 equations, and that's it. Okay? When you get to me in algebra 2, you'll have 2, 3, 4, and 5 equations that we'll deal with. But for algebra 1, for your EOC, you're going to deal with 2 equations. If I have 2 equations, that means that when I graph them on a graph, what should I see? If I have 2 equations, what should I see on my graph? 2 lines. Absolutely. So if I look at this first one, this first example, do you see 2 lines? Yes. What are those lines doing? Intersecting. This intersection point right here, that's its solution. So if I were going to look at this, how many solutions does this have? 1. If I have 2 intersecting lines, I have 1 solution. Now, where is that solution is my next question. So if I look at this graph, where is this solution located? So my x is 2 and my y is 3, so I can write that as an ordered pair, 2, 3. Would you agree? Solutions for systems will always be in the form of an ordered pair. Questions so far? Look at the next set. What do you see? 2 lines? Are there 2? Yeah, and they are, I heard it, parallel. What do you know about parallel lines? Never intersect. So if they're never going to intersect, what can I say about this system? No solution. Very good. The last example, do you see 2 lines? Yes, you do. One's dashed and one's solid, correct? So if I look at these 2 lines, what can you tell me about them? They're the same. They're perfectly overlaid on top of each other. So how many intersection points does this system have? Infinite. Because if they're laying on top of each other, every point on each line is an intersection. Would you agree? Because they're all the same. So this is infinite solutions. I want you to glue this in. That's the first thing to glue in. And then I need you to get out your, you can cut that in half, yes? Go ahead and cut it in half so that you can glue in number of solutions first. And then we're going to go to the full page of graphs, right? The one that you just trimmed around the outside perimeter. We're going here next. And then we'll put in the other half of that page. So I'm going to pause the video so that you can get glued in and get the next page out. When you're looking at the paper that has 6 different graphs on it, all I want you to do right now is I want you to fold on every solid black line. Like fold on every solid black line and make a really good crease on it. Doesn't matter how, you just need to make sure you've got every solid black line creased, and then we'll come together and I'll show you how to put it together. Now if you're watching this video because you're absent, the next few steps you need to get either directly from myself or from one of your classmates who has done this, because trying to tell you verbally won't work. So stay with us. All right, we are going to start with problem number 1 in the booklet you just made. So as I'm looking at problem number 1, I see how many equations? 2. That's what I want to see because I'm dealing with systems. If I look at the first equation, what do you know? Just looking at this equation, what do you know? Slope is -5/4. Good. I know this one is my slope. What else do you know? Y-intercept is 6. Where do I start if I want to graph it? At the 6, which is the y-intercept. So please go put a point there. At 6. And then you're going to use your slope. Yes? Okay, what is my slope? -5/4. What does that mean I need to do then? It's negative, right? So that means from this y-intercept, I need to go down 5. 1, 2, 3, 4, 5. And then which direction? Always right. Always right. 1, 2, 3, 4, 5. 1, 2, 3, 4. Do what? I went down because it's negative. Correct. It would, yes, yes. So I always want to go up or down first, depending on the sign. This one's negative, so I go down first and then always right. Always, unless I go backwards. Okay, we'll do that in a minute. Now go again. Down 5, over 4. Use your ruler. Get yourself a straight line. And your first equation is graphed. Let's look at our second equation. What do I know? Slope is 3 over 2, and it's positive, yes? And then what's my y-intercept? Go to negative 5 first. Going to negative 5 because that's where I start. I always start at the y-intercept. And then from my y-intercept, I use my slope. My slope is positive 3 over positive 2, yes? So that means I go which direction? Up 3 and then right 2. Up 3 and right 2. And I'm going to use my ruler and I'm going to draw a nice straight line. And what do I notice has happened? My lines have intersected. If they intersect, how many solutions do I have? Just one. And where is that solution? Where they intersect, where they cross. So give me a location. How are you going to tell me where is that solution? What is my ordered pair? So 4, 1. Because in order to tell me the solution to a system, you have to know where they cross and what that location is. So what is the ordered pair? So questions here. Okay. Number 2 is all you. If you're watching this on video, you're going to pause at this point. I want everyone else to graph, and then we're going to come back together and check. For this first line, I only ended up with what looks like half of the graph, right? So did you get this far? I was going up 1 and over 3, but I need more graph. So did you go backwards? If you didn't, we need to make sure that since I went up and right 3, up 1 and right 3, to go backwards, I'd go down 1 and left 3. It's kind of a nice trick. If you need more points on a graph, that's the only time you will go left. Okay, so make sure you've gone ahead and you've completed the first line. Pause again if you're still graphing, otherwise stand by for the second line. So the second line, again, I ran into the same issue where I started at positive 1 and I went down 1 over 2, yes? But what am I looking for? I'm looking for where my system will do what? Intersect. And are they intersecting if I'm heading this direction? No, but I can look, and I can look at the way this graph appears, and I know that they are going to intersect, correct? So what I need to do is go back to that y-intercept and back up. So instead of going down and right, I'm going to go up and left. And just so that I can see what's going to happen with my graph. And sure enough, they do intersect. So make sure you're checking your graphs, making any corrections you need to. And where is the solution? Where do they intersect? -6, +4. That is their intersection point. That is their solution. Questions? All right, here we go. Question number 3, look at it. What do you notice on question number 3? Point slope form. Can I graph using point slope form? I sure can. What do I need to know? The slope and the point. Let's find the point first. Looking at this first equation, what's the point? 7 represents what? The y. So this is the y. And 6 represents the x. And so when I pull them out of my equation, they always change signs, yes? So let's write the ordered pair. What comes first, x or y? X. So that means this 6 is now a -6, and this y is +7. There's my point. Let's graph it. So -6, +7. So instead of starting on a y-intercept, I'm just going to start on the point, and that's okay. So from this point, I need to use my slope. So what is my slope? -1/3, yes? So from this point, where do I go? Down 1. Good. Right 3. Down 1, right 3. Could go backwards if I needed to, but it looks like it's going to cover a lot of ground here. Using my ruler, getting a nice straight edge, not like mine. And we're looking at the second equation. Questions? Do I need to slow down? Are you okay? Okay. Looking at the second equation, identify your x and your y just for good measure. And let's write our ordered pair. So what's my x value? +5, correct? Because it's -5 in the equation. So when I take it out, it becomes the opposite. Comma, what's my other part of that? +8, because it's -8 in the equation, so when you pull it out, it's positive. So my starting point is going to be at 5/8. There's where I start from. Good job. So from this location 5/8, what's my slope? 2. What does that mean? I go which way? Up 2 over, correct, because every whole number sits on top of a 1, but I'm already out of graph. So go back to your point, this location of 5/8, and instead of going up 2 and right 1, I'm going to go down 2 and left 1. Just going to move it backwards. And then I'm going to use a ruler, and I'm going to connect those dots, and what happens? They intersect. Because remember, I only got 3 options. They can either intersect once, not ever intersect, or intersect the entire time and be infinite. This has one solution, and that solution is it is at 3, 4. That is correct. As you finish checking this one, your job is to move on to the next question, which is question number 4. I want you to complete number 4. So if you're watching, you're going to pause, complete number 4, and then we'll check together. All right, as you're checking your graphs on question number 4, making sure that you got them graphed correctly, also double checking my work, because we don't want, that'd be embarrassing if I messed up, right? I'm looking for a solution where they intersect. These actually do have one solution at -4, -4. So please make any adjustments that you need to, any corrections that you need to on your graph. Make sure you hit pause so that you can see them. All right, so as we move on to question number 5 and question number 6. So looking at 5, when I open up and I look at question number 5, what do you see? What kind of form? Standard form. Can I graph from standard form? No, so I'm going to have to fix that. And then what else do I see? It's a horizontal line. Absolutely. So and we'll talk more about that in just a minute. But when I have a y equals, that's going to make a horizontal line. So let's first deal with our standard form equation. And I might want to write this in my notebook, and then I can glue my booklet in next to it because I don't think there's enough room in your booklet. So I have 6x minus 7y equals 35. And I know that in order to graph this, I need a different form other than standard. So what form am I going to go to? What's your choice? Slope-intercept? It is the most user-friendly. If I want slope-intercept, what do I need to isolate? What needs to be alone? The y. So I got to get this y alone. That means I got to get rid of everything else. So what do you want to get rid of first? Yes. So this 6x that's positive right here, I want to move it to the other side. So when I move it over there, what's going to happen? Okay, so that means that it's almost like I'm subtracting it. Would you agree? I don't want that to confuse you, but that's what I'm doing. I know when I take it to the other side, I'm just subtracting. And so this is what's happening on this left side. What do I have remaining? Negative 7y. Please don't forget that sign in front. So very good. And then that's going to be equal to what's on the other side. Correct? So, but I want to put it in slope-intercept form. So that means I'm going to have a negative 6x plus 35. So I'm just going to make that do what I want it to do. Now, am I done? No, because I need to get y alone. So what are you going to do? Divide everything by negative 7. And when I mean everything, I mean everything. It's its own division of negative 7. And I write it like that so that we don't forget. So what is negative 7 divided by negative 7? What happens here? It cancels out, or negates. That's such a good word. It negates each other, and so then you're left with a y. And then what happens with negative 6 over negative 7? Do you know how to check it on your calculator? You can go alpha y equals and put it in. Negative 6 over negative 7. And then hit enter. It'll reduce it for you. So alpha and y equals, that pulls up all of your fraction stuff, yes? And then negative 6 over negative 7, hit enter. What happens? It's just 6 over 7. So it doesn't reduce any. It just changes to a positive. Now, if this were going to reduce, then it would do that for you. And that's what you would write down as your slope. Then what is 35 over negative 7? Negative 5. Now do I have something I can graph? Perfect. Where do I start? Negative 5. So let's go ahead and graph it. And then my slope is positive 6, positive 7. So I'm going to go up 6 and over 7. And by my calculations, that's the only other point I can get on there. Like, that's all I have room for. So I'm going to use my straight edge, my ruler. I'm going to go ahead and draw the line for my first graph. Now, the second equation says y equals 1. We've already said that's going to be a horizontal line, but I want you to understand why that happens. This says y equals 1. So that means on the y-axis at 1. That's right here. Would you agree? On the y-axis at 1. That's where my line has to pass. So the only way it can pass through the y-axis is going horizontally. So it's going to pass through the y-axis at 1. This has a slope of 0, and it's horizontal. Now, does it intersect? Yes. How many times? Once. Where? 7, 1. Absolutely. Okay, the very last one in this booklet says x equals 5 and 9x minus 5y equals 35. So x equals 5. When we talked about what happens with a y equals, right? It has to pass through the y-axis at that point. So what does this one mean? Has to go through the x-axis at positive 5. So let's find positive 5 on the x-axis. And I need my line to pass through that. So what kind of line is that going to make? Vertical. What do you know about the slope of a vertical line? Undefined every time. Horizontal line is always 0. Vertical line is undefined. Now I have one more line I need to graph, and I can't do that until I rearrange it. So your job is to put that standard form equation into slope-intercept and get it graphed, and then we'll check. Once you've checked these two equations, making sure that they're graphed right, please make any adjustments that you need to. Locate the solution, which happens to be at 5.2. I want you to glue this booklet in, and then we are headed to the second half of that first page that you still have out, which says solution to a system, question mark, and right system. That's where we're headed next. All right, so we've talked about what it looks like on a graph when you get a solution to a system and how you can locate those things. But what if I ask you, is 4, -3? So is this point 4, -3 a solution to the system? Well, if I had a graph, I could look, right, and see if that's where they intersected. But I don't have a graph. I just have a couple of equations. So what do you think I could do to see if 4, -3 is a solution to this system? I could graph them, but I've still got to rearrange one of them, and bleh. So I could graph them in my calculator and see. Or 4 represents an x, and -3 represents a y. Would you agree? Okay, and if I look at this first equation, do you see x's and y's? So in this first equation, everywhere I see an x, I'm going to replace it with a 4. And everywhere I see a y, I'm going to replace it with a -3. And I'm going to see if it works. And I'm going to show you what that means. So y is -3 equals -2 times what's x? 4 plus 5. Now I want to see if that works. So what I'm going to do is simplify. Can I simplify the left side of the equation? Over here, this -3. Can anything be... Okay, so I'm just going to write it down. -3 equals. Now, can I simplify the right side of the equation? Yes. So what is -2 times 4 plus 5? And you can run it in your calculator and get an answer. Or you can say -2 times 4 is -8 plus 5 is -3. Does -3 equal -3? Yes. It works. So far, I think I might have a solution, but I don't know unless I check the second one as well. Again, plugging in the 4, -3 everywhere you see x's and y's. So this says x plus 2y. So x is 4 plus 2 times what's y? -3. And I want to know, does that equal -2? We got to see if it works. So I can only kind of simplify the left-hand side of this equation. Would you agree? The right-hand side is just a -2. So what is 4 plus 2 times -3? It's -2. Does -2 equal -2? Yes. Is this a solution? Yes. Now, if you'd gotten something that said, and listen, if it had said -2 equals +2, is that true? No. So be careful. Watch your signs. Use your technology so that you know for sure. Questions? Okay. At this point, what we're going to do is we're going to get everything glued in, okay, so we don't lose anything. So you've already glued in half of the first page in your booklet, right? So glue in the second half of the page and the word problem page, and then that's where we'll pick up tomorrow.